Hey guys, welcome back to the channel. In this video, I'll be covering the transformations of functions, the last topic that we need before we start talking about interval notation and also um, polynomials and each classification of functions. Before we hop into the meat of the video, please subscribe to the channel. Also, leave a like on this video. Turn on notifications so you guys get notified when I post videos. Also, comment down below any sort of feedback you guys can give me, and also any is good. Just don't make it personal attacks. And also, comment down below any comments you guys have about the video or any topics you guys want me to cover. Also, don't forget to follow me on social media, YT_ the Swiss Army Tutor, and where you guys could DM me any sort of topics you guys want me to cover. So let's hop right into it. All right, so we've covered algebra functions, and we covered how operations affect other polynomials and stuff like that, or basic expressions. So let f of x, the graph of x, be the parent function. Let me fix that. Let me set it. Sorry guys for the horrible writing. Let that be let's let that be the parent function, the original function that we're going to be working with. All right. So what a transformation means is if we have a curve. If we have if we have a curve, it could go up or down. The graph could go up or down, left or right. It could shrink. It could grow. It could, and it could also reflect. So, different things mean different ways of writing things mean different forms of writing, or transformations. So, and so let's start off with up and down. Okay. Okay, so we have, let's let f be a random curve. It's going to be an easy parabola. I'll cover that, which we won't get into until quadratics, but we'll talk about this. Okay, so let's let this be f of x. All right. So to move the graph up or down, we add or subtract outside, and we add a factor. Let's call that b. Sorry guys, I'm gonna move that over for you guys a little bit. So let's call that b. So if b is positive, we call that, so it translates up. So b is positive. If b is negative, it moves down. Okay, that's simple enough. All right, so and it's read as f of x plus b. So a good example of this would be 3x plus 2. This line was shifted up 2 units. Okay. Now that we've covered up and down, let's talk about left and right. Okay. All right, let's use the same curve. Sorry, guys. All right, so to move left or right, we do a similar operation as we do for up and down, but instead of, let me box this for you guys. But instead of having it on the outside, the plus or minus goes on the inside. So if b is positive, if we're adding, it gives us left movement. And if we have subtraction, we have right movement. Okay, you guys are thinking, Swiss, that doesn't make sense. You're wrong. That doesn't make sense. Well, you guys can always plot in points to prove the point, but it's counterintuitive in this case. I get your guys' skepticism, but this is if b is less than 0 or greater than 0, positive. If b is positive, add. And we move to right b units. Left b units if it's subtract, sorry. If we subtract. And left if we add. There we go. If that makes sense, guys. That's really simple. So up and down. So if we add outside, it goes up and down. If we add inside, and so if we add and subtract outside, it goes up and down. Where up is positive, b is negative. But if we add and subtract inside, by subtracting we go left, and adding we go right, or other way around. Sorry. If we add, we go left. If we subtract, we go right. Okay, so those are the basic translations. We also call that translations. So okay, we have that. Okay, so now we have that piece done. We have reflex or what I call as flips. Sorry guys, let me focus the camera for a second. So focus, sorry. Call this flip or reflections. And it pretty much says the same thing. And so it just copies the graph, but does the opposite. Like kind of like writing in a mirror. It's just a mirror image, pretty much. Where the mirror image is just the opposite. So so we have let f of x be let f be the parent function. So keeping the same curve. Okay. Okay. So sorry guys. So pretty much, if we were to multiply by a negative number on the outside, negative f of x gives us the reflected across x. Meaning it looks like this. Okay. Now, if we have f of negative x, it reflects across. So it reflects across the y-axis. That's why when we had a negative mx plus b, so y is equal to negative x, the graph did this. Instead of doing one of those, okay? So it reflects across the y-axis instead. So last but not least, we have shrinks and stretches. The last piece of transformations. Pretty much a stretch. So stretch / shrink. So let's talk about this for a second. All right, so once again, let f of x be parent function. Okay. And so we're going to go back to our parabola. Okay, so if we have any constant multiplied by f of x, all right, this constant shrinks. Oops, sorry guys. So if we have a number that multiplies by f of x, it shrinks or stretches the graph. And if it's on the outside, if a is greater than 0, it stretches. Vert stretch. If a is less than if 1 is less than if 1 is greater than a but less than 0, it shrinks vertically. So if a is less than 0, it does one of these. The dotted lines right there. This is if a is less than 0, or a if follows this quantity. If 1 is less than a, or if 1 is greater than a but a is less than 0, and then it grows. Then this is the grow across vertically. Sorry, I'm bad at drawing that. That's a stretch. That's if a is greater than 0. Or greater than 1. Well, greater than 0, actually. That makes sense. It'll stretch. But definitely greater than 1, though. For sure. Be safe. Okay, so then we have horizontal shrinks. So if we go back to the same function, and we take a multiplied by x inside of here, we call this a horizontal shrink or stretch. Oops, sorry guys, let me move that over. So if we take a number, that same constant from here, multiply it inside, we call that a horizontal shrink or stretch. So if a is greater than 0, then it shrinks, or then a shrinks vertically or horizontally. And if a satisfies this inequality, 1 is less than a 0, then it stretches vertically, horizontally, which makes sense because if you have a vertical stretch, it'll shrink a little bit horizontally, and vice versa for the opposite. So today we talked about the transformations of functions. So we'll talk more about those and showing how they behave with different types of functions, starting on after interval notation. I'll see you guys next video.